Welcome to our lectures of the DC microgrid and control. We shall continue with our first part, that is the left out portion of the GA and the multi-agent system. Then we shall talk about the energy management in the microgrid system. So, let us see how much portion I can cover today. So, that is the multi-agent system we will discussed. Thereafter MAS, that is a multi-agent systems, is application in the microgrid. Then we shall discuss about the energy management system, and that has some sub part, that is a load forecasting, weather forecasting, demand side management, state estimations, and the power flow module, and the load leveling and the peak shifting. These are very important thing in our, not only in microgrid, but also your normal applications, but also in a normal grid. So, let us continue with our portion of the GA, that is genetic algorithm. So, which was left out in our previous lectures. The performance evaluators rates the chromosome by assigning a fitness value. So, you have to, every chromosome will be tested. Let us say you want to calculate the square of the functions. So, if you give 5, it should give you 25. So, you will accept that 2% error maybe. So, if the value is 24.68, then it is not fitted with it, it will reject that value. If the value is 24.99, you accept it, as simple as that. So, that is the case. The value indicates how good the chromosome is in the controlling the dynamic plant to flow the reference signal. So, you will select those chromosome only. The learning algorithm may use to set the rules in the form of the condition then actions. You had a FLC, that is called if then logic, and here you have a condition then action. If this is a condition, then this is the action. Overshoot is more, then reduce the overshoot. If your settling time is high, reduce the settling time, increase again. The controlling for controlling the plant. The desirable actions will be performed by control action producer when it is satisfied, that is the fitness value. There is a settling time you have achieved within this, you got a peak overshoot within the 2%, fine, then you say that finish. And GA can effectively use to adjust the parameter of the microgrid controller, for example, PI. The overall control framework for this purpose is shown in figure 3b. So, that was in your previous slides. Now, let us talk about the multi-agent system. So, the multi-agent system, it is something very great amount of importance in our microgrid, DC microgrid or AC microgrid, because you have different stakeholders, and the point one microgrid was a net consumer can be the net producers. So, and this entity also the time dependent, it is not fixed. Today most of the houses are the consumers, but in case of the microgrid they are also sellers, and they can have a energy storage element. So, it is a multi-agent system and agent change their behavior, that is the one of the unique features of our microgrid. The MAS, that is the abbreviation of the multi-agent system, is comprising the 2 or more intelligent agent followed by the specific task. The multi-agent systems technology is widely used in planning, monitoring, controlling and the automation system. So, that is the very useful for our modern way of living. In microgrid control, the structural flexibility, that means a source can be turned into the load and vice versa, that is the structural flexibility, and having a degree of intelligence are highly important. So, you have to incorporate into the knowledge that yes, this is possible. In such system, agents requires real responses and must eliminate the possibility of massive communication along the agents. So, an agent can be considered as an intelligent entity which is operating in the environment with a degree of autonomy, specific goals and knowledge. An agent can alter the environment by taking some actions and can autonomously in response to the environmental changes. So, that is also possible. You if you have a shortage of the production for the rainy day or something, then you may cut down the non critical load intelligently, or maybe you require an AC that is operating then maybe at 23 degrees centigrade, without telling you smartly, it keeps the temperature maybe 26 degrees centigrade, and in that way it saves lot of power, and that helps you to maintain the overall comfort level in a microgrid. That is also possible. And the autonomy means that the agent is able to fulfill the task without the direct interventions of the human. Of course, generally in the microgrid there can be a super user, he or she can write off the intelligent control, but generally intervention is kept as less as possible and one person is given the responsibility only. So, you do not have direct human intervention and smartly it can implement the control, and the environment and the environment is everything, the system, hardware, software external to the agent. So, that is something we have a multi-agent system. And so, MAS application in the microgrid power management, this is one of the very important topic to understand. For designing a decentralized power control system in the microgrid, intelligent MAS method can be considered and is an effective solution also. For decentralized power management, 4 kind of agents are considered. One is production agent, that is a solar plant, wind, you may have a fuel cell. Consumption agent, mostly these are loads, but it can be a bidirectional also. Power system agent, that means the active rectifier and all the entry point of this your grid, and MGCC agent. This is all will be discussed in detail, that is basically microgrid current controller agent. So, microgrid controller, that is agents, has only coordinated task. Generally it takes only the coordinated task, and more specifically it is announces the beginning and the end of the negotiation for a specific period and records the final exchange of the power or any entities, mostly power, between the agent in the each period. The main features of the MAS, that is the multi-agent system, is that the software within the each agent can be embedded with the local intelligence. So, it can take its own decisions, you can put ANN or fuzzy logic controller within it, and within a limitation it can take its own decision to give you the optimal control. Each agent uses intelligence to determine the future actions and independently influence the total environment. So, it is a critical load. If it finds that generation is more, then it may actually start the pending work which was been postponed because of the tariff was high. So, this is something it can intelligently do that, you need not have to bother. And this is the overall pictorial diagram or architectures of the decentralized control of the microgrid in the interactive structures. So, this one is a microgrid, another microgrid, another microgrid. This is agent 1, agent 2 and agent 3, and in between you have a local control agent. This is named as LCA, and so LCA can interact directly with a microgrid agent, as well as it can interact among themselves. And if there is an energy surface of this microgrid, of course, it can transfer energy and it can talk with each other to the peers, and overall there is a DNO, that is called distribution network operator agent. This is the ultimate stakeholder of this all small microgrid, and this will monitor and maybe dictate the term sometime to monitor in a different way. This is the centralized structures of the decentralized structures of the microgrid in case of the MAS system. Now, at the higher level decision making body is the DNO. The higher level, that is DNO, corresponds to the an microgrid power network grid level. So, maybe the grid and the micro, all the small microgrid will interact to the DNO, and its agent is responsible for communication between the microgrid and the DNO and the masses exchange regarding the energy market. So, whether your microgrid will sell the energy because of the excess power or will take the energy when there is a demand in the microgrid. So, that DNO will design and set the tariff accordingly. The medium level management is a level in which the agents of all the microgrid coordinate with the local generator or distributed generator, loads controller, market participations and possible collaborations with the adjacent microgrid. The microgrid MGCC controller is responsible for the communication among all the controller inside the microgrid, as well as the external communication with the other MGCC and DN, ultimately with the DNO that we have seen in this figure. So, ultimately it can communicate also with another MGCC or with the DNO to control all distributed generator concerning the economic and the environmental aspects of the power dispatch. Now, let us talk about another issue, that is microgrids are small scale voltage electrical distribution network composed of distributed energy sources that we have told several times, and such as distributed generation system, energy storage system and controllable and the non controllable loads or uncontrollable loads. Now, we have to set or fix a technology to control all of them. These sets of technologies requires a management system. So, this is a power management system of the microgrid, supervising, controlling and planning. Sometimes we require to plan, because you know that in night there won't be any solar. So, we require to increase the state of storage of the storage element, that these are batteries, to some level, and accordingly you may, once you are in a daytime, you may have to shed some kind of loads then, and planning its operation while guaranteeing an efficient, economical and the reliable performance. So, it should not have any power cuts, that is the requirement. And then what? Forecasted data can be used to schedule the operations of the distributed generations. When you have a forecasted data that solar will be this much of generations, wind will be this much of generations, and the ESS during the finite operations, finite operating horizons, and the mismatch will be fed into or taken from the storage element in agreement with the forecasted loads consumptions with the renewable generation. So, forecasting is one of the major part of the microgrid, and we require to have a forecasting quite reliably, otherwise whole system can be messed up. Now, the estimated electrical variables such as the nodal voltages and the branch current must be within the technical limits. So, we generally apply the droop control in case of the DC microgrid. So, how much amount of the droop will be allowed in case of the environmental changes, that has to be in a technical limit, as well as the stability and the frequency regulation if it is a AC microgrid of the electrical distribution systems that compose the microgrid. Since the management functionalities of the microgrids deals with issues of the different technical areas, time scales and also infrastructure level. So, you may have time scale that has to be sustained for 1 hour, and it may be 6 hours somewhere, and also different kind of infrastructure. If it is a hospital, you got a lot of critical loads, and if it is a mall, then you have a very small amount of critical loads, mostly in lifts, or you may have emergency lights up to some extent. So, then infrastructure level also will take a clause of your control system, and so we require a hierarchical control schemes has been widely accepted as a standardized solutions. So, who will control what? Local control will be there, some extent if it is a communication between two microgrid. So, someone has to, they will talk with each other, and upper level in DNO there will be another hierarchy. So, adoption of the hierarchical control schemes become more relevant. Please note our different kind of control system, master slave, peer to peer and hierarchical control. So, what we are saying in the multi MA system, you got the hierarchical system that has found to be advantageous, and the control scheme becomes more relevant when it is used to analyze the different processing time required to execute the main process at such control level. And for this reason, we require to cut the autonomy in the peer to peer network, and it cannot operate in a master slave board, because all the burden will be on the central system. And for this reason, we require to delegate the power. Some will be taken by the local administration, something like that, and some will taken at the central level. So, same way we have a hierarchical protocol in case of your in case of your also the power management system for the microgrid. First, fast dynamic control of voltage and frequency of the DER unit is used to maintain the system stability. distributed energy resources, that consist of the generations and the storage element, it will be used for the maintaining the stability. The second, a slower dynamic control is deployed for the long term economic dispatch. And then the idea behind these control levels is that each level operates within own. So, it depends on the processing time, you got a data inputs, and you got an infrastructure requirement, whether how many critical loads are there and how much power cut you can allow for the small interval of time, or how much you can allow to change over. These are the issues. In general, the hierarchical control schemes comprises the 3 different levels. The primary levels responsible for local control of the energy distributed energy resources, and the second level generally it deals with the primary deviations in the variable of the frequency and the voltage. In AC microgrid these are frequency and voltage, in DC microgrid it is the voltage, and thus you got an advantage. The tertiary level, which also known as the energy management system, that is EMS, which introduce the intelligence to the system to manage and coordinate the operation optimal power flow between the different microgrid as well as the main grid. So, that is called the tertiary level of control. Now, what we are talking about in much detail, that is the energy management system. It is a holistic information based on forecasting, load sharing, load forecasting, weather forecasting, planning, all are the entities of the energy management system. So, an EMS, that is energy management system, can be defined as comprehensive, automated, no one does, no human being, but you can employ the human beings right options, but it is generally automated, and real time system used for the optimal scheduling and management of the DES and controllable loads operating within the electrical distribution system. So, there are uncontrollable load also. So, that is something we require to understand which are the uncontrollable loads, and that also we require to take a purview of something in a controllable loads. The EMS provides the data management, grid informations, supervisions and control over the automated DGs and ESS that compose a microgrid. Now, let us talk about the energy management system and what are the entities and the scope of the energy management system. The main functions of the energy management systems are, these are the follows: maximize the each customer's energy availability and thus increasing the system reliability. So, you require to say no to the load shedding, and if you are saying this thing to the rural India, please see that what kind of achievement you are going to achieve, where getting power was a challenge. Minimizing energy losses. So, we require to efficiently manage our energy, so that transmission distribution losses are being minimized. And there are many issues, not only electrical issues, there are also issues related to the commercial aspects, and that required to be also minimized. Operational costs, gas emissions and the fuel consumption. If you have a support of the DGs, and that increases the costs, diesel generator, not distributed generator. and that will emit and pollute your neighborhood, and this is also a cause of concern. Minimizing the issue of the renewable energy, maximizing the usage of the renewable energy and minimizing the use of the fuel based power, and also minimizing the energy purchase outside the microgrid. You try to cut your coat according to your cloth. So, you require to spend the whatever you generate in the microgrid and try to have a least power demand from the main grid, and if possible try to feed that power to the grid. Managing all the distributed generations and the energy storage element and controllable load in case of the resynchronizations with the microgrid. That means, we have seen that we have a different kind of control mode, PQ control mode. Once you have connected to the grid connected mode, once you have a offline or the islanding mode, you are in a V/F control in case of the AC microgrid, and also you may, if it is a, we apply the droop control in case of the DC microgrid. Those all manage, some portion of it can be have a droop control, some portion, the portion which you fail to make it a DC microgrid can be a AC microgrid, and thus you go for the V/F control. Now, what are the typical applications of this energy management system, that is EMS? Require datas, we require lot of input data and require a very fast processes, that is a two requirement, and thus require huge amount of transducers. First, forecast the non-dispatchable generator units. This is generally the renewable sources, how much solar will generate, how much wind will generate, that you should have a data. Forecast of the electrical and the thermal loads. Thereafter, energy pricing. Unfortunately, in India, for the domestic purpose our pricing is same. We do not bother to actually add on more consumption even at the peak hours, but we require to have a dynamic energy pricing depending on the availability of the energy and the state of the charge of the storage element, if it is a battery, operational and the security and the reliable constraint of the network. So, if whether it should not be hacked by the hackers or the terrorists, so that all those problems may come up and mess up. Informations about the common coupling point at the main grid, that also to be known. All the data is gathered by the EMS, is deployed to set the control actions by the different kind of controller, and mostly we prefer in this case hierarchical control. And the objectives of this actions are to reduce the total operational costs of the microgrid and the generate the bill, that is the paid by the customer, that will be required to be minimized. So, this is multi objective, you require the reliable power, and but also you require the consumer should pay less, and you have a different kind of control level also. And thus, what you require to do, money saved is money earned, decreasing the network losses, emissions and the enhancing power quality, reliability experienced by the consumers. So, you got a power anytime. It is not that you supply power when you have a surplus. It is very important you should able to supply power to the consumer when they require, and thus this term is quite important. Accordingly, the EMS provide the output information to the utility level, that is the importer exporter or the power purchaser, importer exporter power from the main grid to the DES level, dispatch or the connection or disconnection scheduling, and to the load level, the load shedding or the curtailment of the load. These are the few aspects of the energy management system. We shall continue our some portion left out of the energy management system, then forecasting and other issues in the next class. Thank you for your attention.